welcome to this video. Today we are going to discuss about the quantum behavior of light. In this video we will discuss about the Planck's quantum theory actually. So first article is a history of quantum theory, how quantum theory is developed, that we will see in this particular article. Okay, now you know that there are different types of mechanics which you have studied in last year: classical mechanics, statistical mechanics, quantum mechanics. These are the different types of mechanics. Generally classical mechanics is applicable to the objects which are having size greater than 1 micron. If the object is having size greater than 1 micron, the study of such objects undergoes the classical mechanics. Okay, now generally classical mechanics is based on the different types of laws. That laws you have also discussed or studied. Generally classical mechanics deals with the Newton's laws of motion, laws of gravitation, Coulomb's law of charges, and Lorentz force law. You know that there are three laws of motion which was proposed by Newton. So first law states that if any system is in state of rest or in continuous motion, it will remain in the state of rest or continuous motion unless it is not influenced by any external force. That law is known as Newton's first law of motion. So this law gives the definition of inertia to us. Newton's second law of motion is that any applied force is directly proportional to the acceleration produced in that body. Means F is equal to ma. Mathematically it is given by, if F is a force and m is the mass of the object and a is the acceleration produced in that body, so F is equal to m into acceleration, and that is the second law of motion, Newton's second law of motion. Third law gives action and reactions. If F12 is the force exerted by the first body on the second body, similarly F21 represent the force exerted by the second on the first. The action and reactions are the equal and opposite in direction. Means action means the force exerted by the first particle on the second body, and F21 is represented by the force exerted by the second body on the first. Okay, so F12 is equal to minus of F21. Minus sign indicates that the two forces are in opposite direction. So this is the third law of Newton's law of motion. Then law of gravitation. Newton's gravitational law gives the force between two masses. If m1 and m2 be the two masses of the bodies, and the force of what is the force between the two masses is given by the Newton's law of gravitation. This law states that the force of attraction between two masses is directly proportional to the product of their masses and inversely proportional to the square of distance between them. If two objects or two masses are at a distance r, which are separated by the distance r and having masses m1 and m2, the force is proportional to the m1 into m2 divided by r square. That is the force between two masses. Okay, that proportionality constant is given by capital G. It has value 6.67 into 10 to the power minus 11 Newton meter per kg square. Okay, that is a law of gravitation. Then third law is Coulomb's law of charges. The force of attraction, it is analogous with the Newton's law of gravitation. When it gives the force of attraction between two charges, point charges, which are separated at a distance r. That force of attraction or repulsion is given by Coulomb's law of force. That is given by force of attraction between two charges is directly proportional to the product of charges and inversely proportional to the square of distance between them. Again, fourth law, actually if Lorentz force law, actually Lorentz force, it is a force due to electric and magnetic field. If Q is a charge on any particle and E is a electric field, B is a magnetic field, then Coulomb force is given by Q into E plus Q into V cross B. Actually this is the Lorentz force law. So these are the laws on the basis of that classical mechanics is developed, and classical mechanics, laws of classical mechanics. So these laws have some drawback. These laws could not explain some other phenomenon like a black body radiation. Black body means the body which absorbs most all the energy which is incident on it. Such a body is known as black body radiation. If we provide energy, or if we increase the temperature of the black body, it emits some radiation, and it has some characteristics wavelength. That process, how it will happen, what is the energy distribution within the spectrum of black body radiations, that things are not satisfactorily explained with the help of these classical laws. So to explain such laws, we what are the things which are not explained with the help of classical laws? That is black body radiation. Then photoelectric effect. Photoelectric effect means when a light of suitable frequency is incident on the metal surface, the electrons are ejected from the metal surface. That electrons are known as photoelectrons, and this process, this phenomenon is known as photoelectric effect. So why photoelectric effect is occurred or observed in case of metal, that could not explain with the help of this classical mechanics, or the laws of classical mechanics. And again, the energy distribution inside the black body radiation, that is not also explained classical laws. So we have to develop the new approach of that law. So that is called as Planck proposed that quantum theory of light, or introduced the idea of quantum theory. Okay, in 1900, Planck's quantum theory were developed. Okay, according to Planck theory, light is composed of energy. Light, it is in the form of bundles, that bundles are known as quanta. So each quanta is having some specific amount of energy, and it is quantized. Quantized means it has some fixed amount of energy. Okay, so that energy is given by E is equal to h into nu. Actually, if h is called as Planck's constant, and it has a value 6.6 to 6 into 10 to the power minus 34 joule second. Okay, so that is a value of h, and nu, it is the frequency of radiations. Actually, if more is the frequency, more will be the energy. That's why if you look at the electromagnetic spectrum, it is ranging from the radio waves to the cosmic rays actually. So that's why the energy of ultraviolet light is greater than the visible light. So why? Because visible light has less frequency than the ultraviolet light. So energy is given by h into nu, where h is the Planck's constant, and nu, it is the frequency of radiations. Okay. So this concept, the concept of Planck, or concept of Planck is used for explaining the photoelectric effect by Einstein, and he gave it to name of quanta, that is photon. The photon is a name given by the Einstein, and so to develop this Planck's quantum theory, Planck assumed some things. What are the assumptions which were assumed by Planck? So any black body, or the walls of the atoms of the wall of the black body, acts as a simple harmonic oscillator. They are vibrating about the mean position, and it assumes that simple harmonic oscillator cannot have any arbitrary values, only those values of energy that is given by, it has only those amount of energy, it is given by E is equal to n, sorry, this is A, it is h nu, actually this is A, not A, that is h nu, sorry. So instead of A, it is h, okay, that is h. So where n is equal to 0, 1, 2, 3, called as quantum numbers. If harmonic oscillator does not oscillate about the mean position. That's why n is equal to 0, means n is equal to 0. For n is equal to 0, oscillator have 0 energy, okay, 0 joule energy. And if it is equal to 1, it is equal to 1 h nu. So this means that energy cannot have any values. It has some fixed amount of energy. It cannot have 1.5 into h nu value, okay. So that is called quantization of energy, means it has some fixed value, okay. Then oscillator is in the state cannot absorb or emit the energy. Such a state, in particular state, cannot absorb or emit energy. That state is known as stationary state, okay. It is absorb or energy or emit energy only when it is jump from any particular state to the, if it is absorbed, it absorbs energy when it is jump from lower state to the higher state, and it will emit energy when it came from higher state to the lower state, okay. So absorption and emission takes place only when it will goes from one energy state to the another energy state, okay. So that is E2 minus E1, okay. If any system is or any state, if E2 is the energy of higher state and E1 is the energy of lower state, the E2 minus E1, that is the energy difference, is given by N2 minus N1 into H into nu, okay. So that is a difference in the two state, okay. Now the interaction of light with the matter is better explained using the concept of photon rather than wave. Means the concept of interaction of light and matter is well explained in concept with the help of concept of photon rather than wave concept. Light has a dual nature. Actually, sometimes it behaves like a wave or sometimes it behaves like a particle. It has a dual nature, and the interaction with the matter is explained with the help of photon rather than wave, okay. And if generally energy of photon is expressed in terms of electron volt. Electron volt is a unit of energy, and generally photon energy is expressed in terms of E into nu, okay. E into phi, okay, that is electron volt. If we know that E is equal to h nu, h it is the Planck's constant, nu is the frequency. We know that the relation between frequency and wavelength, that is nu is equal to c pi lambda. If we substitute the value of hc divided by lambda, E is equal to h nu, means it is equal to E is equal to hc by lambda. H into c, if we substitute the value of c means velocity of light, so it is 3 into 10 to the power 8 meter per second, and value of h is equal to 6.626 into 10 to the power minus 34 joule second. If we substitute the value of that into h nu formula, we will get a product of that is given, it is used by 12,400 divided by wavelength. Actually we have to convert this joule into electron volt. So for that we divide it by charge on electron. Charge on electron is 1.6 into 10 to the power minus 19 coulomb. So product of H into C is divided by the charge on electron. So that gives us the 12,400 and into 10 to the power minus 10. So that's came in the wavelength. So if we have to given or we have to calculate energy in terms of electron volt, this is the formula. It is equal to E into E, it is equal to 12,400 divided by wavelength. Okay, if any wavelength is given in terms of angstrom and we have to calculate the energy, use this formula. With the help of that we can easily calculate the wavelength, the energy of that radiations. Okay, so this is about the quantum behavior of light, how it is behave like a quantum and this is a theory proposed by quantum theory of light. So this is about quantum behavior of light. I hope you will better understand this video. Thank you for watching. Thank you.